Then coming to the last topic of the chapter, heating effect of electric current or effects of electric current. When electric current is passed through a conductor, three changes are takes place. Three effects we are able to observe. One is heating effect, chemical effect, and magnetic effect. The magnetic effect of electric current will be learned in the next chapter, electromagnetism. Then the chemical effects of electric current already learned in class C. Chemical effects of electric current. Then one more is heating effect of electric current. So what is this heating effect of electric current? When electric current is passed through a high resistance wire, that resistance wire gets heated, become hot and produce heat energy. That effect is called as heating effect of electric current. So the electric bulb glows because of when electric current is passed through the conductor like a bulb. The filament of the bulb made by tungsten, it has more resistance. Due to passing of electricity, the tungsten filament gets heated, become hot, turns into red hot and produces heat energy as well as light energy. Such effect is called as heating effect of electric current. The heating effect of electric current is obtained by the transformation of electrical energy into heat energy. The electrical energy is converted into heat energy. So in case of mechanics, like if we roll a ball on the ground, the ball is stopped because of force of friction. Here the force of friction opposes the movement. Similarly, the resistance of a conductor, opposes the movement of the electrons in the conductor. As we know, the flow of electric charges in a conductor is called as electric current. So the characteristic property of a material or the substance which opposes the movement of electrical charges is called as resistance. Of the matter. Since a conductor like a resistance wire offers resistance to the flow of current, but we need to do some work to flow the electric charges. In a conductor, we need to do some work. So work done W is equal to Q into V. So Q is the electric charge. Total electric charge is passed through. So that work done to move electric charges into one point to another point can call as the potential difference. So work done W is equal to Q into V. As we know, current is equal to total charge or amount of electric charge transferred in a second, in a 1 second at a particular time. So current I is equal to Q by T. From this, you can write Q is equal to I into T. As we know from Ohm's law, V is equal to IR. Substitute this Q and V in equation 1. You can get W is equal to Q means I into T. V means IR. So I into I square, T left and R. This electrical work done is equal to amount of electrical energy. This amount of electrical energy is converted into heat energy. So heat energy produced or energy produced by electrical work done, H is equal to I square into R into T. This heat energy produced is equal to work done. Heat energy is equal to work done. Work done is equal to I square into T into R. So H is equal to I square into R into T. R into T. So energy we can measure in terms of joules. Electrical energy or energy we can measure in terms of joules. By observing this equation, H is equal to I square into R into T. Heat energy produced is directly proportional to square of current. Heat energy produced is directly proportional to resistance of resistor. Heat energy is produced directly proportional to time. If more time current is produced, heat energy produced more. If the resistance of the resistor is more, then heat energy also produced more. When current is more, so if the double the current, that heat energy produced, if double the current, the heat energy is produced increases 4 times. So all the appliances which run on electricity do not convert all electrical energy into heat energy. Only the heat electrical appliances convert most of the electrical energy into heat energy. For example, when electric current is passed through a fan, here a fan acts as a resistor. It has some resistance. When electric current is passed through a fan cannot convert this electrical energy into heat energy, but it converts into mechanical energy. So most of the electrical energy in case of a fan converted into mechanical energy. Very little amount is converted into heat energy. So if the fan is run for a longer time, so when we touches it, we can feel some hot. Because all the electrical energy cannot be converted into heat energy. But in case of electrical heaters, in case of electrical iron, most of the electrical energy is converted into heat energy. Electric geysers, electric heaters, electric iron. So in this case, such kind of electrical appliances convert the electrical energy into heat energy. Because of the components or the heating elements are made up of highly resistance, the material which have high resistance like nichrome, tungsten, etc. So this is about heat energy. Then let us solve one problem, then we can conclude the chapter. One problem, then stop the chapter. So here heat energy is directly proportional to square of current. Heat energy is directly proportional to resistance. Heat energy directly proportional to time. More time more energy produced. If the resistor has more resistance, heat energy produced more. If the current increases, then heat energy also increases. Then one problem. Calculate the heat produced. Calculate the heat produced. Calculate the heat produced when 96,000 coulombs. 96,000 coulombs of charge. 96,000 of charge is transferred in 1 hour through a potential difference of 50 volts. A potential difference of 50 volts. First of all, let us calculate amount of current is passing and resistance. Then we calculate the heat energy produced. First calculate amount of current flowing. So given Q is equal to Q nothing but electric charge. Amount of electric charge. Q is equal to 96,000 coulombs. 96,000 coulombs. Right? Then time given T is equal to 1 hour. That is equal to 60 into 60. 3,600 seconds. Then calculate current. Current I is equal to, we know, Q by T. Current I is equal to Q by T. That is equal to 96,000 by 3,600. So zeros get cancelled. Then when we simplify it, we get 26.67 amperes. Current to 26.67 amperes. Then what is the formula for heat produced? H is equal to I square into R into T. We calculated I, current. We know time. Then what are the resistance? Then now calculate the resistance. Voltage given in the problem. Voltage V is equal to 50 volts. Nothing but potential difference. This is the first one. This is the second one. Voltage V is equal to 50 volt. According to Ohm's law. V is equal to IR. According to Ohm's law, V is equal to IR. From this, you can write R is equal to V by I. That is equal to R is equal to V 50, current 26.67. So after the simplification, we get resistance 1.87 ohms. So now we have current, resistance, time already is there, 1 hour. Then we need to calculate the heat produced. Then third case, heat produced. H is equal to I square into R into T. I square is equal to R into T. So that is equal to 26.67 square into 1.87 into 1. By simplification, we get 4,788.40 joules. 4,78,840 840 joules. This should be converted into kilojoules. 4,788.4 kilojoules. So amount of heat energy produced. Amount of heat energy is produced. This is about our chapter electricity. Here application means concept and understanding concept is little easy, but application is the very important. Problems are the very important. So practice the problems. Practice all the problems perfectly. Different methods, different formulas we have. So whatever you need to practice the problems. So thank you so much, and please subscribe. Watch the videos regularly. Share my channel to your friends and relatives who are studying class 10. Thank you.